Okay, and here we are in our next section, 1-3, perpendicular bisectors. Now I want you to notice I've drawn a line segment AD. And what we're going to do is we're going to draw a perpendicular bisector. Now you should recall that this word perpendicular means that two lines are intersecting at 90-degree angles. And you might be wondering, what does the word bisector mean? What do you think? What does it mean to bisect something? And it means to cut in half. And I bet about half of you got that, to be honest. So a perpendicular bisector will look something like this. It will be a line that forms a 90-degree angle, or kind of looks like a cross or a plus sign. So it's a 90-degree angle. And let's give this two letters. So why don't we call this one C, and let's call this one B. And so what would we say here? We would say that CB perpendicularly bisects, I promise that is an S, bisects AD. So CB is perpendicular bisecting AD. That means that AD is getting cut in half. Now, what does that mean? That means that this left side right here is equal to this right side right there. And we can draw one tick mark here and one tick mark there to show that these two segments are congruent. What if I drew two tick marks here? How many tick marks would I need on the right? Well, I would need 2. And this raises an interesting question. If these two segments are equal, what is that point right there? Can you think back to our past geometry lessons? What would we call this point right here that is exactly in the middle of AD? Well, I'm going to call it M, where we would say that point M is the midpoint. Okay. Now, we use this word congruent, and we're going to learn some statements of congruency. In fact, let me write that down, and I would encourage you to write that down as well. Statements of congruency. And it's been my experience that students kind of struggle with this at first. So if this seems a little confusing at first, don't worry. You're going to pick this up very, very quickly. But here's what we're saying. We're saying that AM is congruent to MD. We're saying that AM is congruent, and there's our symbol for congruency, to MD. And all that means is these two things are equivalent. But we can actually come up with 4 more statements of congruency. So for example, we know that AM is half of AD. And I would ask you, how many halves does it take to make a whole? And I would hope that you would say 2. So if I had 2 AMs, well, that would be congruent with the whole thing. And how would we say the whole thing? We'd say AD. Now that's not the only thing we can multiply by 2. Instead of multiplying AM by 2, we could have multiplied 2 times, what do you think? Yeah, that's right. 2 times MD, this segment on the right. And that would be congruent to the whole thing, AD. Okay, but what if we talked about the whole thing? What if I took AD, and what if I were to say, what if I said AD is congruent to AM? Is it true that the whole thing is congruent to the half? No. So I'd actually have to take AD, and I would have to cut it in half to make that a true statement. So if we take a half of the whole, it will equal the part. And of course we can do one more of these. Now let's see if you can get this on your own. What is the other thing that we could say half of AD is equivalent to or congruent to? Correct. MD, that other piece. These 5 statements of congruency will really drive so much of the math that you're going to work through this year. So let's go ahead and put these in practice. I encourage you to pause it, finish taking the notes. Let's move on to our second example. For our second example, we have AB is bisected by CD. Now I want to stop right there. AB is bisected by. If it's being bisected by, what does that mean about AB? AB is in fact being cut in half. Excellent. And so if AB is being cut in half, that means that AE is this segment right here, and EB is that segment right there. Or I could put 2 tick marks right there and 2 tick marks right there. Could I put 3 tick marks on either side? Yeah. 4? Yeah. So long as they have the same number of tick marks, it is telling us that they are congruent. And let's write that congruency statement. We're saying that AE is in fact congruent to EB. And this is going to be our simplest form of congruency. Okay, so AE is congruent to EB. And let's take a look at what things we know. Okay, so we know AE, I use this a little darker, is 2x plus 3, so I can write 2x plus 3. And we know that EB is going to be 6x minus 8. And wait a second, what do we know about these two things? We know that they are congruent, and so we can just take this AE and plug it in right here. So we'll say 2x plus 3. And remember, when using algebra, we don't use congruent, we use the equal symbol. And EB is going to be 6x minus 8. Now this is going to require some new math. You know this from Algebra 1. We're just shaking off the rust. But the difference in this equation from everything that we've seen previously is this has an x on both sides. So what should you do when you have an x on both sides? You should always, always, always move the smaller x first. And I'll write that. Move smaller x. I have so many students who don't move the x's first, and they get confused. They say, Mr. Hastings, I don't understand what to do. But if you move the smaller x first, after they do that, they know how to do it. So let's take a look. What's the smaller x, the 2x or the 6x? 2x, of course. And how do we get rid of a positive 2x? Well, minus 2x. And remember, you can draw this little dotted line through the equal sign if you must. And we put the minus 2x. We always line our x's up with our x's and our constants up with our constants. So we have a 0 pair, and we would say 3 is equal to 6x minus 2x, which is 4x minus 8. Now, how can we get rid of a minus 8? Well, of course, we would plus 8 and plus 8, and 3 plus 8 would, of course, give us 11 is equal to 4x. Now, from here, we know this is very simple. We divide both sides by 4. We get this. X equals 11 over 4. Or, if you wanted to, I would actually encourage you to use your calculator, and I would encourage you to get a decimal. And so the decimal is a little bit easier to work with. That's going to be 2.75. Now, what is the question really asking us for? Because it's not asking us for x. That is not the answer. It's asking us to find the length of AE. And so kind of like last time, I look at AE, and I see that AE is in fact equal to 2x plus 3. And remember, all we do is we simply change that x to a set of parentheses plus 3. Let me even, denote this. Hey, here's our x. It's 11 over 4, or 2.75. And so we can plug that 2.75 in there. And all we have to do is multiply those two things first. We have 2 times 2.75, which will give us 5.5 plus 3. Now remember, when adding a decimal plus a whole number, you can just add the front numbers. And of course, 5 plus 3 would give us 8.5. And so this line segment, AE, is equal to 8.5. And by the way, if this is 8.5, how long is EB? 8.5. And what if I asked you for the whole thing? Well, you do 8.5 plus 8.5, which would simply be 17. So the cool thing about these is once you know one part, you can always find the other part or the whole very simply by either adding it with itself or multiplying by 2. Alright, let's go ahead and let's do one more example. I would encourage you to pause this, write down your notes. Let's move forward. Alright, now here's our last example for this section, and you should be becoming so comfortable, so confident with the math. I'm actually going to move through this one fairly quickly, and I want you to see and feel what it should be like when you're comfortable and confident with the math. So, given the construction below, we're given that AM is equal to 15 inches. So here's AM, it's 15 inches, and MB is 3 parentheses 2x minus 1, and of course that's right there. Now I want you to notice something. See how you have these arcs right here? Whenever you see something like this is called a construction of a perpendicular bisector, and we'll really dive in on this hands-on when we get back to the school. But this will always indicate that M is our midpoint, and these two line segments here are congruent. Now remember our simple statement of congruency, which is that AM is congruent to MB, and from there we can plug in the things we know about AM. We know that AM is 15 inches and is equal to MB, which is 3 parentheses 2x minus 1. Now I included this example because you need to remember distribution. So on the left we have 15, but on the right, anytime you have a number outside the parentheses, we need to multiply. So 3 times 2x will be 6x, and 3 times negative 3 will be, or 3 times negative 1 will be negative 3. Now from here, we know we get rid of our subtraction first by adding. They are opposites, and 15 plus 3 would of course give us 18. We drop the 6x, and of course our zero pair goes away. Now how do you get rid of that 6? Well, we divide both sides by 6, and x is equal to 3. Look how quick and easy that was when we feel confident with the math. Now one final thing, this says find the length of MB, so we know that, let me use a different color here. We know that MB is equal to 3 parentheses 2x minus 1. I would always encourage you to simplify first. 3 times 2x is 6x minus 3, and then from there we can go ahead and plug in our x value. Remember, we always change our x to a parenthesis first. We can plug in x, and of course now we can finish this off. We can say that 6 times 3 is 18 minus 3, and 18 minus 3 would of course be 15. Now I want to show you one final thing. I showed you the math because you need to see the math. You'll have to do this math someday, but this question asks what was the length of MB. You already knew that that was 15, and you knew that that was equal. If you had recalled that, you could have just said MB was 15 from the start. Alright, I wish you good luck on this section, and I'll see you in our next section lesson.